Hello, in this video we are discussing mathematical operation on continuous time and discrete time signal, and that operation is time scaling. As it is an operation on time independent variable time, we can call it as a transformation of independent variable, and that is nothing but time. Let's start. Time scaling of a signal is obtained by multiplying time variable by some constant. Let's suppose x of t is a continuous time signal, then its time scaling has a two version. In one case, we are multiplying this time with the constant a, and in another case, we are dividing the time by a constant. So x of at or x of t by a are nothing but time scaling operation. We are scaling the time with some constant. X of at is a time compressed version of x of t, and x of t by a is a time expansion version of a x of t. Real-time example of time scaling is, let x of t is the tape recording. Then x of twice t is nothing but time compressed. So x of twice t is the same tape recording played at a twice period, played at a double period. And x of t by 2, it is expansion version, and this is a nothing but the same time recording played by a half speed. So in case of this tape recording operation, the compressed version means nothing but we are increasing the speed of that tape recording, and expansion version is nothing but we are slow down the speed of that tape recording. Now let's see this time compression. That means we are multiplying time with some constant. This is nothing but speed of increase the speed. When we increase the speed, particular time slot required is less. And graph your graph or your graphical representation of signal is it shrinks. Similarly, time expansion, so in time expansion, we divide t with some constant. That means we'll slow down the signal. Slow down means time expands. That means graphically the signal expands. Let's see with the example. This is your original sequence x of n, and we want to do the time compression, means we will multiply this n with some constant. Let x of twice n we want to do. That is, we want to compress the signal by double, twice n. So same process, mark x of n as a x of n dash. That means this time axis becomes n dash, and this n dash we want to transfer to the twice n. That means this n dash is equal to twice n. Then for each value of n dash, minus 3, minus 2, minus 1, we'll calculate what is n. N is n dash upon 2 from this formula. So how this formula n dash we want to transfer to the twice n. Why we are labeling the time axis as a n dash and n? This n dash is time axis of the original sequence, and this twice n is the time axis of a time compressed signal after your operation on the signal. So n is equal to n dash upon 2. So for n dash is equal to minus 3. Minus 3 by 2 means n is equal to minus 1.5. So n dash is equal to minus 3. It becomes n becomes minus 1.5. Now n dash is equal to minus 2. N is equal to minus 2 by 2, that is minus 1. So whatever the amplitude available at n dash is equal to minus 2 will shift at n is equal to minus 1. Similarly, n dash is equal to minus 1. It will shift to the minus 0.5. N dash is equal to 1, it will shift to the 1 half, means n is equal to 0.5. N dash is equal to 2, n is equal to 1. So whatever the amplitude at n is equal to 1 will get shift to 0.5, and n is equal to 2 will get shift to the n is equal to 1. Similarly, n dash is 3. Whatever the amplitude at n dash is equal to 3 will shift to the n is equal to 1.5. So you can check here, n dash is equal to 3 will shift to the n is equal to 1.5. If you check the shape of the signal, the original sequence is this one. Its time duration is -3 to 3. Where in a time compressed signal, your signal compresses and your time slot compresses, it becomes -1.5 to +1.5. This is time compression. Similarly, you can try the same operation with the continuous time signal. Here, see, your time slot is -2 to 1. And if you want to compress it by 2 time unit, so for the same process, x of t will mark it as x of t dash. Time axis will make it as a t dash. And when t dash is -2, -1, 0, 1, we'll calculate t using this. T dash we want to convert to the twice t. So t becomes t dash by 2. So in this formula, we'll keep t dash is equal to 2. What is t? -1. Means whatever the amplitude at t dash is equal to 2 will get shifted to the t is equal to -1. And t dash is equal to -1 will shift to the t is equal to minus zero point 0.5. T dash is equal to 0 will shift to the same, t is equal to 0. So your sequence, this will get compressed. So -2 to 0 time slot becomes -1 to 0. Similarly, t dash is equal to 1 will get shifted to the t is equal to zero point 0.5. So this portion also gets shrink. Amplitude remains same, only the time slot or the shape of the signal gets shrink by 2 time unit. This is the time compression operation. Similarly, you can try time expansion operation. I told you time expansion means slow down the speed, means your signal expands. This is your original sequence. We'll mark it as a x of n dash, time axis n dash, make it table. We want this n dash should be transferred to n by 2. It is time expansion. Previously it is time compression. This n dash we transfer to the twice n. Now here n dash is equal to n by 2. Time expansion. So n becomes twice n dash. So for n dash is equal to -3, -2, -1, 0, 1, 2, 3, we'll calculate what is n in a time expand signal. You can check. N dash is -3. That amplitude gets shifted to the n is equal to -6. This one. N dash is equal to -2 amplitude gets shifted to the n is equal to -4. Similarly, n dash is equal to -1 amplitude gets shifted to the n is equal to -2. Then n is equal to 1 amplitude gets shifted to the n is equal to 2. n is equal to n dash is equal to 2 amplitude gets shifted to the n is equal to 4. N dash is equal to 3 amplitude gets shifted to the n is equal to 6. You can check the shape of the signal here. The time period get expands. Here time slot of this signal, original signal is -3 to 3, and here it becomes -6 to 6. So same operation you can try with the continuous time signal also. Here mark it original sequence as a x of t dash. Time axis become t dash. Then this is the table. T dash we want to transfer to the t by 2. That's why t is equal to twice t dash. T dash is equal to -2, -1, 0, 1. Calculate t. T becomes -2 amplitude get t dash is equal to -2 in a original sequence get transferred to t is equal to -4. T dash is equal to 0 will remain same at t dash is equal to 0. T dash is equal to -1 amplitude gets shifted to the t is equal to -2. So this time slot from -2 to 0 expands, -4 to 0 becomes -4 to 0. Similarly, t is equal to 1, t dash is equal to 1. This amplitude gets shifted to the t is equal to 2. So your sequence becomes like this. This 0 to 1 time slot becomes 0 to 2. It doubles because we are expanding by 2. You can check the shape of the sequence. In a original sequence, whatever the time slot get expand, it get doubles here. This is the time expansion operation. You can try with the another type of sequence. Suppose this x of t is given to you and you want h of 4t. That means you have to compress the signal by 4 time unit. So this 2 amplitude at 2 becomes at 2 by 4. Amplitude at 1 becomes at or transferred at 1 by 4. Amplitude at 0 transferred at 0 by 4. So you can try this on your own. Similar, this one is time expansion, h of t by 4, and this h of t by 4 again it get multiplied by 4. That is called as the amplitude scaling. One is done for you, h of t by 4 expansion. Your original sequence get expanded by 4 time unit, and then it get multiplied, amplitude of each get multiplied by 4. This amplitude scaling you can understand in a next video. So this is about time compression and time expansion. Time compression means graph sinks, the speed increases. For example, tape recording we have checked. Whatever the tape recording, if I compress the time or if I do the time compression operation, that tape recording get play with the twice period. Time required is less as graph sinks. Similarly, in a time expansion, whatever the original time slot expands. In the same tape recording, after time expansion, get play at a twice period or expanded period. Time required to play that will be increased. So this is about the time compression and time expansion. Thank you.